Hello dear students. So here I will explain the part C from the chapter refraction through lens, sign convention and lens formula. It's very easy thing, so you need to just listen very attentively. That sign convention means what will be the sign of the when the object is placed. Okay, what will be the sign when the object is placed any side of, suppose the convex lens. So suppose this side object is present or this side, what will be the positive side, another will be the negative side, like this way. Okay, similarly for concave, the one side will be positive, another side will be negative. So that sign convention is needed to understand the actual distance from the optical center to that object. Okay, to the object means where the image will from that, or the original position of the object. That we all need to we will understand when we understand the sign positive, negative. Okay, which will be positive side and what will be negative. So student, very attentive, very easily it has written in your book, and I'm just giving the point, you just remember. Okay, so always in numericals, when there will be a numerical, suppose concave or convex lens will be given any one according to your syllabus. So middle, that is the optical center. Okay, it will be the optical center. So all distance you will measure from the optical center, first point. Okay, you just remember it, or you can check your book page. Okay, there it has mentioned the optical center of the lens is chosen as origin of the coordinate system. So from the optical center we will measure the distance of the object or distance of the image form. Okay, now second point is object is considered to be placed on the principal axis to the left of the lens. So object, second point, placed on principal axis and left of the lens. Okay, left side and on the principal, not here that here a objective will place, not like that. On principal axis left side of the lens we will consider. Okay, whenever a numerical will be given, that a object is placed 10 centimeter away. Okay, that means left side 10 centimeter from the optical center of the given lens, concave or convex, whatever it will be given. Now third, all distance measure along the principal axis from the optical center of the lens. The distance of an object from the lens is denoted u. Suppose here is the object. Then from optical center, this distance is considered as u, and the distance of image here, the suppose here the image form, that will be considered as v. Okay, that is the third point. So 3 point you measure. First, optical center is the main center, coordinator of the coordinate system. Second point is that all object always placed in the left side. Third point is that distance or optical center to the object is u, and optical center to the suppose here mirror image will form, then that distance is called v. Okay, you just remember this thing. And the distance of second focus, okay, focal length of the lens denoted by f. Okay, just remember this thing, second focus or focus is denoted by the f. Okay, and third is that distance measured in the direction of incident ray are always taken positive. You just remember this thing. Suppose a light ray fall from this side, that means this side, the distance measured in the direction of incident ray, okay, is always positive, while opposite of the incident ray is taken as negative. So from this side light is incidence happened, so from left side we will consider means that is positive, and from this side if we come towards the left, that is be negative. From just think about the arrow, positive, negative. Okay, so if the incident ray is like this way. So once again I am just showing you the form 3 rule here, lens maker formula. The formula 1 by f is equal to lens, just once come to the lens formula once again. Student, if derivation is not needed because it is not present in your syllabus, only just you need it for the numerical purpose. So I will solve some numerical also, so that's why I am showing you. You just remember the formula and some rule two or three rule I explain over here, and another sum also I will write over here. So you just remember this, or you can remember like this way: 1 by v minus 1 by u is equal to 1 by f. It is also same, okay, or 1 by f is equal to 1 by v minus 1 by u. Okay, v is the object image distance, u object distance. I already explained this thing, okay, and here it is focal length, f is the focal length, okay. Mm, so now students, do some numerical. One thing, just sign convention once again I'm saying, focal length for a convex lens is always positive. Just remember this thing. If convex lens has given in the numerical that there is a convex lens, its focal length is 10 centimeter. Suppose it has given a convex lens, focal length is given, focal length is 10 centimeter, that means plus 10 centimeter always. And for concave, that is always negative. Okay, so focal length for a convex lens is always positive. You will put the positive sign, and when the numerical will be given, there will be no sign will be there, but when you will solve it, you need to put the sign, okay. And for concave lens means that will be negative. All distance are measured from O, means optical center, from optical center all distance measure, okay. So all distance we need to measure from the optical center, that I explained previously. I here also I told you, okay, all distance optical center is the main of the coordinate system, so all distance we need to measure from the optical center. Distance measure in the direction of incident light is always positive, that I explained already. From, suppose from this direction the light ray is going, so that is the positive direction, this side. When we will calculate from left to right, that will be positive, and from right to left, then that will be negative. You just remember this thing. Now height above principal axis positive, so above that is positive, and below this side also below will be negative, okay. So above principal axis, any case concave, for concave also student remember this thing, above that is positive side and below that is negative. Here also below side will be negative. Height above principal axis is positive. One you just remember, another will automatically you. Now just do a one numerical. I am right, I already complete did over here, here. So here you can see, suppose a convex lens if has given, focal length has given 10 centimeter, an object placed 20 centimeter from convex lens, that means focal length is always positive, f is plus 10, okay. An object placed 20 centimeter from lens means left side 20 centimeter, okay. Find the position of the image, okay. So formula, lens formula, 1 by f is equal to 1 by v minus 1 by u. Now students remember this thing, object placed 20 centimeter from lens, okay. See, that is the convex lens. For convex lens, you know, focal length positive I have written. Now object is placed here, suppose 20 centimeter from the lens means from the lens, so this direction we are coming means this direction is negative because incident ray will form from this side, that is positive. So incident ray, this is the incident ray, so incident ray is positive. Suppose incident ray is falling here, that means the opposite direction we are coming, we will calculate all the distance from optical center. So from optical center, that is opposite direction, that means negative sign we will use, that's why u will be, and that will be u, object means u, so u will be minus 20. You just remember, those have understand this thing, no numerical will be a deal for you, easily you can calculate all the numericals, okay. Now position of the image, just put the value minus 20 in place of u, okay, and if that will be plus 10, okay. So calculate, you will get the value plus 20, okay. Plus 20 means right side, okay. So it will come like this way, or suppose here the object is there, so it will come fall and in this direction. Minus 20 means plus 20, plus 20 means this direction, okay. Here it will be, here will be the object, okay. Means same distance from the optical center object will form, okay. Same distance object will form means where the object is placed, that you know, all know, in the convex lens, okay, in ray diagram, I think in second focus or somewhere like this, okay. Okay, now come to another numerical. I am you just check your book. Okay, I am saying doing in example page number 125. Okay, there I am doing one math, one numerical. First, suppose an object height 4 centimeter placed at a distance 24 centimeter from a convex. So convex 4 centimeter height. Okay, put how distance placed at a distance 24 centimeter. 24 centimeter means this is 24 centimeter and u will be minus 24 centimeter, you know, because incident ray from this direction, that is positive, that is negative. Okay, so now come to the thing. Object height is 4 centimeter, place distance from length, focal length 8 centimeter. Focal length f will be given always positive. Okay, means plus 8 centimeter for as convex. That's why you check page number 125 Selena publication book. Okay, I'm explain, it has calculated already in book, but I am explaining. Okay, so that will be negative. And image means, okay, so O, that height is considered O is equal to 4 centimeter. That I will explain the relation between m and m is equal to I by O. That will be that I will explain after some time. Just remember here. Okay, as it has given without explanation, I need to solve the math now. Okay, so if u we get, first calculate the v. 1 by f is equal to 1 by v minus 1 by u. Okay, then we will get, you put the value f 1 by plus 8 is equal to 1 by v minus 1 by minus 24. From here you will get the value v. V is equal to 12 centimeter. Student, just remember this thing. Okay, that position of the image. Okay, position of the image, you get that it is 12 centimeter. Okay, and you can write that 12 centimeter plus value has coming means behind the lens, behind the lens, because if object is here, so 12, object is 20 centimeter this side u, and v will be plus 24 centimeter means behind the lens. Okay, and what the relation this I by o, that I am explaining. Okay,